Relative velocity. To work out the velocity of one moving object as seen from another moving object, you add a velocity opposite to that of one object to both objects. Then you find the resultant velocity in the usual way. Let's look at an example. Here we have two aircraft. The black aircraft is flying at 700 km per hour due north, and the grey aircraft at 1120 km per hour due west, taking paths something like this. First, we effectively stop our plane relative to Earth, our plane being the grey one, by adding the opposite velocity vector to it. But we must then also add this velocity vector to the other plane's velocity, the resultant giving the other plane's velocity relative to us. So, the other plane, the black plane, had a velocity of 700 km per hour due north. Our plane had a velocity of 1120 km due west. So we must add the opposite of this, which is 1120 km per hour due east. The resultant along here will be found by Pythagoras, and this comes out at 1320 km per hour. The angle theta here we can find using tan theta is 1120 over 700, giving an angle of 58 degrees east of north. So if we were sitting on the grey plane, the black plane would appear to be approaching us along this line. If the black aircraft is 40 km due south of the crossing point, when the grey aircraft is 67 km due east of the crossing point, find the displacement of the grey aircraft from the black one, and state whether the planes are on course to collide. That's if they're flying at the same altitude, of course. Well, first we put on the displacement vector for the black aircraft, then for the grey aircraft. This then is their resultant, which we can find by Pythagoras to be 79 km. We again need to give an angle, and in this case tan theta is 67 over 42, which is again 58 degrees east of north. So their displacement is at the same angle as their relative velocity, so they are on a collision course. How long will it be before they are at the closest allowable separation of 60 km? Well, time is equal to displacement over velocity, and the displacement they need to cover is the current 79 km minus the minimum allowable separation of 60 km over their relative velocity of 1320 km per hour. This gives a time of 0.014 hours, or more usefully 52 seconds.